So, good morning. In the subject of engineering thermodynamics, today we are going to see two boilers. Okay. So, one is a Babcock and Wilcox boiler, and second is Cochran boilers. So, today's lecture having only 3 slides. So, one slide for first boiler and second slide for Cochran boiler. But there is a lot of time required to explain all these boiler working and their mountings and accessories. So let's start today's video. So first is a Babcock and Wilcox boiler. It is also called as horizontal boiler shell because it's a boiler body, that is a generator, steam generator, that almost horizontal where the steam is generated. So it is also known as horizontal boiler. So this is a basic structure, basic layout for Babcock and Wilcox boiler, where it is mainly constructed with bricks, then some part with a metal shell. There is fuel burner, and if coal is used, solid fuel, so there is a furnace which having a grate and ash pit. So this is a basic construction, basic layout for Babcock and Wilcox boiler. Now we will see how to add the parts and how those parts are working in this boiler. So there are two headers. Headers in general language we can say a manifold or a big channel. So upper header and lower header. So there are two headers. This is upper header. This is bottom or lower header. These two headers are connected with your boiler shell, where the actual water is supplied, feed water is there, and steam is generated. So these two headers are connected to this boiler shell, and these two headers are interconnected with the help of water tubes. Water tubes, that means the tubes where water will be there. Boiler tube, you can say a boiler tube. This is basically there is a categorize of any boiler. Either it is a water tube boiler or fire tube boiler. Then what is the difference between these? So when we say it is a water tube boiler, that means whatever be the tubings are there, boiler tubes are there, water is flowing through that tubes. So it is called water tube boiler. If the flame, that fire, whatever be the fuel, it may be a gaseous fuel, it may be a liquid fuel, it may be a solid fuel, just like coal. So whatever be the fuel burns, so hot gases if flowing through that pipes, then it is categorized as fire tube boiler. So very simple. If tube carrying water, then it is called water tube boiler. If tube carrying fire, then it is called fire tube boiler. So this is a water tube boiler, having one bottom header, one upper header. Bottom header, as compared to upper header, it is always little bit lower. And in bottom header, there is another separate compartment, or the space is provided, that is called mud box. This is the mud box. Why mud box is there? So even though we supply a filter water, that is removing all the impurities, but dissolved impurities remain always there in water, and that dissolved impurity get collected at this bottom mud box. When it gets saturated, we open that mud box and all mud get removed out. So for that, this is a mud box where all the water impurity gets settled down, and after a particular time period, that is servicing time or periodically, we have to clean this mud box, so all the impurity will remove out. Now next, there is a one manhole. Remember, it is a manhole, not a main hole. Okay. So manhole, why it is provided to shell or boiler? So this manhole allow any person to enter inside and do any correction or maintenance work. So that is called manhole. Next, there is walls. Some are safety walls, some are steam supply walls, some are measuring devices, some are controlling devices. So all these are which are the mounted on the boiler to measure or control its operation, that is known as mountings, boiler mountings. So manhole, safety valves, water level indicator, pressure gauge, all these are known as a boiler mountings. This is superheater. So when steam is generated in a boiler, it might be in a dry saturated, it might be a wet steam, but if we superheat it, so our power output by utilizing that steam will be increased. Now how to superheat that steam? So whatever be the steam generated in a boiler, there is a superheater. Superheater through this steam, generated steam will enter, and this superheater is open in a firebox. Firebox where actual fire passing through. That's whatever be the fuel burns and hot gases passing through the path. There we provide a superheater tubing. So superheater tubes taking steam from boiler shell, allow it to pass through that fire zone. Due to fire zone, whatever be the steam intake, that gets superheated, and then this superheated steam will allow for output to provide to supply to any power prime mover or for any application purpose. So we are not directly using generated steam. We are using that generated steam first to allow to pass through superheater. Then superheated steam is actually used for the application purpose. So remember, there are always confusion. What are the boiler mountings and what are the boiler accessories? So accessories are those devices, equipment which is used in boiler to increase or to enhance its efficiency. And boilers mountings are those devices or equipment which are used for control purpose or safety purpose of the boiler. Safety devices or all the boiler mountings are necessary for operation of that particular boiler. That means there should be a manhole, there should be a safety valve, there should be a water indicator. Without all these mounting, it is not possible to run your boiler. But boiler accessories are meant for enhancing the boiler output, just like a superheater. If there is no superheater, then also boiler will work and generate a steam. The case is that we don't get that much output from that steam. To increase that output, we are using a superheater. That means without superheater, there is not a big issue. You can't say that without superheater, I can't run the boiler. No, you can run it. Only the efficiency will lower. So all those accessories which are used to enhance the efficiency of this whole setup, that is a boiler, it is not a mandatory requirement, but it should be there to enhance overall output, overall efficiency. So boiler mountings are necessary equipment devices. Boiler accessories are not a mandatory devices, but it is used to enhance or increase the output. This is a pressure wall through which we can allow our superheated steam for any application. This is here we are showing a solid fuel furnace. That means suppose there is a coal. Nowadays, liquid fuel is used, gaseous fuel is used. Suppose there is a coal. So we have to supply that coal. Coal is supplied into the furnace and there is a grate. Grate, that means we can say screen. So when fuel get burned, so whatever be the ash particle will fall down and collected in ash pit. And there is a separate door for ash pit. When we open that ash pit door, we can remove the ash. So furnace is there. Now with the help of feed water connection, remember feed water connection, boiler itself having a very high pressure. So when we supply any feed water because we are feeding that water for generating a steam. So when we supply the feed water, it should not be like that. The inner pressure will push water outside through the feed water connection. So feed water connection always having a one-way wall, non-return wall. That means water can be enter into the boiler, but it cannot be removed from the boiler, even though boiler inside pressure is high. So with the help of feed water connection, non-return wall, we supply fresh water, removing all impurities before supplying it. This is ash pit door. Now, some more doors are there which are used for any maintenance or cleaning purpose. Even though ash or that fire gases, it provides one carbon layer on these water tubes. These are the water tubes where actually steam is generated. So on the outer surface, carbon layer is deposited, and carbon behave like a resistance. It not allow your fire to come in an actual metal wall surface of this tube. So frequently we have to clean these surfaces so that our efficiency of boiler will be increased. Efficiency of boiler means what? It means whatever be the heat generated by burning of fuel, how much amount of heat is actually utilized to generate a steam. That is called the efficiency. So if imagine there is a carbon deposition on all these tubes, so some part of heat will not be utilized to generate a steam because of that layer of carbon. So efficiency of boiler will decrease. So we have to frequently, periodically, we have to clean all these tubings to remove all these carbon deposition. That is, there are many methods, chemical method, or the very simplest is scratching. So with the help of scratching, we can remove that carbon layers. Now this is a downtake heater. So water is by gravity supplied to this downtake heater. Whatever with the heavy impurities get collected in mud box, and water will be there in these tubes. And as soon as we start our boiler, that means when we start the burning of fuel, so hot gases will evolve. So due to this water in downtake heater, water level will be rise in these pipes, that is water tube pipes. So at the beginning there are waters in pipe, but as soon as burning of gases, hot flue gases start traveling, so it is expected these hot flue gases remain as much as possible in a contact of this water. That means tubes. So we provide a baffles. Baffles it just a divergence. These black shaded, these are the baffle plates. If I don't provide these baffles, so what happen? My exhaust hot flue gases will travel and it will directly shift it to this chimney. Now, as I provided these baffles, so my hot flue gases will be travel first upward, then downward, then again upward, and at last it will move towards chimney, smoke box, and through chimney it will exhausted in atmosphere. So with the help of these baffles, what I did, I allow that hot gases to remain for more time in a contact of these water tubes. So hot gases transfer heat to the water which is flowing through these tubes. There is no pump system, there is no external means for circulation of water. So by gravity, there is water in downtake heater. That water level will rise in these tubes, water tubes, when burning take place. So hot gases will come in a contact of these water tubes. So your water density will decrease. It move towards upward side and cold water will replace it. After some time, we observe that hot water become saturated and steam start generating. So this steam generated and collected into the upper sphere of this boiler shell. So there are two different phases normally observed in a boiler. That is, bottom is your liquid phase and top side generated steam is collected. Now as the generated steam is not having that much potential to provide a high intensity work output wherever the application is there. So we use a superheater. So this superheater collect this generated steam and allow to pass through this superheater. This superheater is actually inserted into the firebox. So when firebox heat is supplied to this generated steam, the generated steam becomes superheated, and when we operate this pressure valve and allow steam to for any application, so superheated steam will be supplied, and as steam is superheated, so no doubt our output will increase. Now remember, there are many boiler mountings, but due to limitation I don't show everything here. But there is a water level indicator. That's means before starting your boiler you must know how much is the water level. Why? Because if there is not sufficient amount of water, then whatever be the heat supplied, it is not utilized for completely, it is not utilizing for generating steam. So excess heat is start to heat up the all metal parts, and we found that there is a formation of thermal cracks, bending of pipes, whatever be the joints are there, it get leaked. So overheating problem is there. So always observe what is the recommended water level. For that there is a water level indicator. Secondly, another mounting is there, that is called a fusible plug. In a pressure cooker, you observe that there is a fusible plug, hexagonal shape, one button kind of structure is there on a lid of your pressure cooker, and that is the fusible plug. If you closely observe that, so that fusible plug at the center, it is a black material is there. So imagine if your cooker don't have a sufficient water there. So whatever be the heat is supplied to your cooker, it is not utilizing for generating steam or cooking the food. So that heat supplied, where it is going, it is heating your overall body of pressure cooker. And might be possible after some time it will blast. To safeguard this, there is a fusible plug. So when your pressure cooker body get heated, so your fusible plug also get heated, and inside the fusible plug, that center material is such a material which get melted at a particular temperature. We select a fusible material such that it will get melted at particular temperature. Suppose your pressure cooker blast was possible at 150 degrees centigrade. So we will select our fusible material as at 100 degrees centigrade. So when your pressure cooker reach to 100 degrees centigrade, your fusible plug will melt and your excess heat will be removed out. So your pressure cooker remains safe, it will not blast. Same kind of function is used in boiler. There is a fusible plug, especially near the furnace. In most of the cases, near the furnace, there is a fusible plug. Suppose this is the part of fusible plug. So what happened? Suppose there is insufficient of water. So excess heat will start hitting your overall boiler. Before your boiler get damaged, your fusible plug material get melt, and whatever be the water inside this boiler shell, it will fall into the furnace and your fire get extinguished. So if there is no fire, no heat supply, no more damage to your boiler. So for that purpose, there is a fusible plug. Pressure gauges are there. So pressure gauge, it is showing how much pressure is there, because we never supplied steam as it is generated. We have to wait for having a sufficient pressure. So there is a pressure gauge mounted on a pressure shell. So when this pressure gauge is showing sufficient amount of pressure is there inside the steam, then only we operate steam valve. Steam valve is nothing but a supply valve. There is some safety valves. Safety valve, again I am giving you that pressure cooker example. There is a whistle. Actually that whistle is nothing but a dead weight safety valve. When steam is generated inside the pressure cooker, your safety valve will not lift. But if that steam pressure reach to certain level, then we observe that our safety valve get lifted due to that excess amount of steam, and excess steam will release automatically. And once your pressure cooker steam restore its pressure for which that safety valve is provided. So once pressure restore, your whistle settle down again. Now imagine what happened. I put a heavier whistle there on a same pressure cooker. First time it is a lighter whistle. So for a small pressure rise, it will lift and release the excess pressure. But suppose I replace that whistle with a heavy whistle, high weight. So your pressure cooker will wait till the pressure sufficiently rise to lift that heavy vessel, and then after it will release the pressure. That means how much weight of that vessel is there, that much pressure will build in your pressure cooker, and that weight is dead weight because it is not going to change. So that kind of safety wall is known as dead weight safety wall. We will check out how these walls and all these accessories are working in details in next session. But overall, what is the accessories mountings, how the steam is generated, how superheater is there, all these are should be aware of before we starting how the actual safety wall work, how the steam wall is working, how fusible plug is works. Okay. So ash pit, whenever a coal is get burned, so ash will be there. With the help of this ash pit door, we open it and remove the ash. Now second boiler. Second boiler is Cochran boiler. It is a vertical shell boiler. You might be seeing a very small size in diameter, and you can say it is little bit portable. You can shift that boiler from one place to second place. This is a basic structure of Cochran boiler. There are tubes, no doubt, but Cochran boiler is a fire tube boiler. Why? Because now whatever with the hot gases, burning gases will flow through these tubes. So this is a fire tube boiler. Water level indicator. Before starting your boiler, you must know how much is the water. Manhole, pressure gauge, then feed water or blow off cork. So blow off cork is there. Blow off cork is used to remove out all the impurities and muds. So periodically we have to open blow off cork, and whatever be the impurities settle down at the bottom side of your boiler water section. So all water along with mud, it is removed out. That is blow off cork. Then feed water. So as I said, it is a one-way wall, non-return wall. So water can enter. Again, this spring pressure, it will lifted this wall and water will enter into the furnace. But due to furnace pressure, it is not possible that steam or water will enter into the feed line, because that furnace pressure assisting this wall to get close. This is a fusible plug. It is mounted in such area where if it get melted, so your fire get extinguished. So fusible plug central, that green color having such a material which get melted at a particular temperature and safeguard your boiler for any kind of thermal damage. Now suppose with the help of feed water, we feed water in your boiler. Now we supply coal or fuel, and when furnace get on, that is fuel burn, so hot gases are evolved. Now in Cochran boiler, all these hot gases enter into the tubes, and from the tubes it is passing towards your smoke box. This is a smoke box, and with the help of chimney, it is exhausted into the atmosphere. Now in this tube carrying a fire, hot gases, so it is called fire tube boiler. And surrounding to this tube there is a water. So when fire passing through this tube, it transfer heat to surrounding water, and your water get heated, then it reach to saturation, then after steam starts generating. and that generated steam will get collected at the top dome of your Cochran boiler, where steam get collected, and with the help of steam valve we can supply it for any application purpose. Whatever be the ash content is there, we have to remove that. So your coal is kept on a grate. As it get burned, your ash content fall down and collected into ash pit, and from this ash pit we can remove the ash. There is some doors, channels through which we have to supply air for burning of your coal. So this is water tube and fire tube boiler. Water tube boiler is Babcock and Wilcox boiler. Fire tube boiler is a Cochran boiler. Accessories and mountings. Mountings are the essential parts without which you can't run your boiler. Mountings consist pressure gauge, stop valve, fusible plug, water level indicator, blow-off cock, manhole. Accessories are those devices or equipment which are used for enhancing the boiler efficiency. But boiler can be run without all these accessories. So it is not a basic necessity to run the boiler.